again in quadratic equations, and in this particular lesson we are going to focus on the formula for finding the sum and products of roots for the quadratic equations. First, let's recall the standard formula of the quadratic equation, as it is ax squared bx plus c equals to 0 for sure. So as you remember, we have studied so far many different methods to find the roots of this form of this equation or quadratic expression, like the common factor, like completing square, and the formula, and splitting, this which is the most common, the splitting middle term method. What was splitting middle term method? It was taking b, if we divide it over a, we'll take b and split it into two numbers, for example q and p, so that q and p, or q plus p, which is the sum of q and p, equals to b, the middle term, and there are another condition, which is the product of p and q, which is equals to c. Where did we get this formula from, and why it's supposed to be like that? Why the root's supposed to be like that? Let's see together. If p and q are the roots for this formula, then the factors will be x minus p and x minus q. So if we did not divide by a, for sure we have to include a in the formula, or in the factors, with the factors. So the factors are a multiplied with x minus p multiplied with x minus q. Let's expand this. Let's expand this together. So we have a here, x multiplied with x gives us x squared, then x multiplied with minus q gives us minus qx. Now minus p multiplied with x gives us minus px, and minus p multiplied with minus q gives us plus pq. We shouldn't forget the a, which is the x squared factor. Let's multiply all the expression with a, so we will get x squared minus a. First, let's take a common here. Okay, a, we have here or q minus p. Let's take first a, x squared minus q plus p x plus pq. This is the better formula now, and then we will multiply with a, which is ax squared minus a or q plus p x plus a pq. So when we expand the factors, we get this ax squared minus a multiplied with q plus px plus a multiplied with b multiplied with q. Now let's together just compare. We are going to compare what with what? The expanded formula with the standard form of the equation. So let's see, we have here in the standard form a x squared plus bx plus c. So this is the standard formula and this is the expanded factors. So we have an expanded factors here, a x squared, and we have here a x squared. We have here ax squared, bx, and c, which is plus and plus. And in the expanded formulas, we can see here we have ax squared and we have minus a. This is the middle term. Multiplied with q plus b. And we have here a p q. So it is obvious that ax squared, and if we equalize these, minus a p plus q or q plus p, doesn't matter, equals to b. So p plus q equals to minus b over a, which is the middle term here, which will be the middle term. And from the last or the constant term, we obviously see that a p q equals to c. So the product of the factors supposed to equal to c over a, which is the constant term after dividing the equation over a. So as we know that in factorizing the quadratic equation, the first step is to divide all the terms over a. Then we will get x squared plus b over x plus c over a equals to 0. b over ax plus c over a equals to 0. So that when we split the middle term, the roots q and p must, the sum of them equals to the middle term b over a, and the product must equal to the last or constant term, which is c over a. So this is the product and sum roots formula. Let's take some examples on this formula. And it's not nothing new, just it's already a formula that we used to work in splitting the middle term factorization quadratic equation, but we need to just prove this formula and see where did it get from and why it's supposed to, the root supposed to sum equals to the middle term and the product supposed to be equal to the constant term. And then now we know, and I hope it is clear for you. So the results that we get in quadratic equation ax squared plus bx plus c equals to 0 over a. So x squared plus b over a x plus c over a equals to 0. If p and q are roots for this equation, then P multiplied with Q supposed to equals to this, C over A, and P plus Q supposed to equal the middle term, B over A. So let's see some examples, which is this, the product, and this is the sum, and that is what take its name, the product and sum of roots formula. See some examples. For example, what is an equation whose roots are 5 plus square root of 2 and 5 minus square root of 2. These are the roots. I mean, this is Q and this is P. So, as the formula says, the sum of these roots supposed to equal C minus P over A, and the product supposed to equal the middle term, the constant term C over A. So the formula should be x squared plus b over a x plus c over a equals to 0. Now we need to find c over a and b over a, which are can be calculated from the formula of sum and product. So first, the sum p plus q, which are these, the root, supposed to be minus b over a. Now the product of root, or the sum of the root is plus 5 plus the square root plus 5 minus the square root of 2 equals to minus b over a. Now this is positive and this is negative. Now we have only 5 plus 5, which is equal to 10. So the middle term is minus 10. And the sum, or the product, which is 5 plus square root of 2 multiplied with 5 minus the square root of 2, it is the full square. So it is equal to 25 minus 2, which equals 23. The product supposed to equal to the constant term, which is equal to c over a. Now c over a, or the constant term, equals to 23. So we can here find that x squared, or the equation is x squared minus 10x plus 23 equals to 0. And this is the formula. Let's see another example. We have here what is the equation whose roots are for example 5 and 2. The same, we need to use the sum and product formula. The sum p plus q equals the middle term minus b over a, and p multiplied with q equals to the last or constant term. So the standard formula is x squared plus b over ax plus c over a equals to 0. We need to find two terms from the formula. So the sum of roots 5 plus 2 supposed to be minus b over a. So b over a equals to minus 7. And the product is 5 multiplied with 2 supposed to equal the constant term c over a, which is equal to 10. C over a equals to 10 and the middle term equals to minus 7. Now let's put them in the formula and we will get the equation, the real equation, x squared plus the middle term here equals to minus 7. Minus 7x plus 10 equals to 0, and this is the standard formula. If you need to check your solution, you just try to factorize this equation that you get. So when you factorize this equation, you need to get the same roots, or that is all for the formula of sum and the products. I hope it was easy and clear enough, and see you again in next class.